Hello, everyone. Thank you for coming to our presentation.
We will explore the topic of threat modeling in general, how it evolved over the years, and how it may look like in the future, and especially how AI might shape it. We will cover the basics, so what threat modeling is, what was the evolution, what tools and techniques we have now. We will also have some demo in the middle, so get ready for that.
As presented, my name is Marta. I'm a principal cloud security engineer.
And my name is Grzegorz Kmita. I'm a threat prevention engineer. Okay, let's start with the foundations. And before that, I want to ask a quick question. How many of you have heard of threat modeling before? Can you raise your hands? Okay, and how many of you have ever done threat modeling? Okay, nice. So, for those who don't know, let's start with maybe not so technical example. So the history of threat modeling brings us years ago to prehistory when people were just living in the caves. So imagine you are a caveman and you want to protect yourself from threats that might happen. And you naturally think of what can happen. So a predator, a wild animal can attack you. And what you can do, you can sleep in a cave. So they did that. You can die out of hunger or dehydration. So you eventually start to farm to bring food closer to your place. You can also suffer from diseases or infections, and you learn to avoid poisonous plants and isolate sick members because you know that they can spread the disease. Maybe a little bit, an example closer to our times. Imagine you are going on vacations. So the worst thing that can happen is that your vacations are ruined, but that doesn't mean anything because that's an empty word, to be honest. So we naturally start to think, what can go wrong at every stage of our trip? So we can miss a flight. So you naturally start thinking, okay, maybe I should leave a little bit earlier, so maybe there is no taxi available, maybe there will be a queue at the airport, and you leave home earlier. Maybe you will have health issues during your trip, so you can break your arm or you can get food poisoning. So you learn what are the medical procedures in the country you're going to. Do you have a valid insurance and stuff like that? Maybe you will have your travel document expired. You won't have visa or your passport has expired. So you check before that, okay, my passport is valid for another 2 years, I'm safe to go. Or there is no visa required. And eventually, maybe something will happen to your home while you are away. So maybe your house will be flooded or will be robbed. So you take an insurance or you ask your neighbors to watch your flat. And we do all those things naturally because we think that maybe something might happen and we want to protect from that things. And if we do that from day to day, why shouldn't we do that to our software as well?
Actually, we don't have a specific date that can be considered as the beginning of threat modeling, but we can try to identify some events that gave rise to this work, such as in the 18th, CIA triad has become increasingly popular. In 1999, Stride framework was created. Then, in 2000, new methods and frameworks have been created. And in 2004, Microsoft created the software development lifecycle process. The last 15 years can be actually called as a boom for threat modeling because we have a lot of new methods, frameworks, tools, standards, and approaches. And thus, we are getting to the definition of threat modeling. Threat modeling is a process of identifying potential threats that may pose a risk to the product and applying controls as a form of protection against threats. There are numerous benefits of doing threat models, like deliver more secure products by building security early into design, possibility to find security bugs earlier and prioritize them for mitigation, address issues that may not be found by other techniques, like, for example, static application security testing won't find missing security controls, better understand the product, and strengthen compliance by meeting regulatory requirements. And why threat modeling is so important? Mostly to find gaps and risky places and fix them before attackers will do that. And one of the actually tragic example of this may be 2 crashes of Boeing 737. Of course, we are not saying that a threat model would have prevented them, but it could have highlighted a few issues. And in this case, unfortunately, 346 people die, company lost reputation, and more than $20 billion. And we see that on the right, we have things that may cause this situation. And maybe in case of preparing threat modeling and focus, for example, of the design of projected systems, maybe the company would be able to improve that situation.
Okay, so we know what is threat modeling and why it is important. So let's go through some basic approaches that we can take when doing threat modeling. So there are actually 3 main approaches depending on what you want to focus on. So at first, you can focus on assets. So those are valuable things you want to protect or an attacker might want to get. So for example, if it was your house, you would care about things that you value the most. For example, the family or some pictures or some documents, whatever that is. And for software, it might be passwords, it might be credit card numbers, or a little bit more high-level things. For example, business plans or reputation. And this approach works very well for security experts and less technical folks, because for software engineers, they tend to not understand the concept of an asset, and they find it hard to identify what assets might be in their system. And for those people, for software engineers, the best approach is a system-centric approach. So you model your software first, and then you model what kind of threats might happen to your system. At the end, we might expect software engineers to know their system the best, and they understand it. So it's the perfect example of who can use this approach. And the third approach is an attacker-centric approach, which is specifically for security experts who knows what kind of attackers and what are their motivations. So in this approach, we try to understand who might want to attack us, what do they want to get, and how do they want to get that. And as an examples, we have insider threats, corporate espionage, or organized crime groups, which are the most popular. And we covered the approaches, and I also wanted to talk about the framework, which is very simple, and it might simplify this process a lot. So those are 4 questions that you will ask yourself while doing threat modeling. And at first, you are going to ask yourself, what are you working on? So what are you building? You can also try to identify assets. Although it is a different approach, you might want to combine that, but it's not really recommended because it only includes like confusion and not really a value. But at first, you are going to build the diagram. The second thing to do is to identify what can go wrong. So by identifying attackers, you might understand what they want to do, how they want to do that, but also you can use other methods to identify threats. Sorry, use some common checklists or methods and tools that we will cover later. The third question is what can we do about that? So how are you going to address the threats? You don't need to mitigate all of them. For example, sometimes the threat is so unique and so improbable that you might just want to accept the fact that it can happen. Sometimes you might want to completely eliminate a threat by eliminating a feature. For example, I don't know, closing a port that is open or whatever. And the fourth thing, the last one, is asking yourself, did you do a good job? So did you correctly draw the diagram? Can you tell the story based on this diagram? Did you identify threats and mitigate them or address them in some way? And that's a loop. So anytime you do something new, you just need to repeat those 4 steps. Okay, we had 2 non-technical examples with the cavemans and going for a holiday. Now let's cover one that is technical. So this is a very simple example of let's call it a web app that shortens your long and overwhelming URLs into short, shareable ones. So at first, at the entry of the system, we have a human user or a service which requests an action. It can be either shortening or redirecting based on what URL it has to the API server. It can shorten the URL, and the shortened URL process will create this URL mapping and store it into the database. Another time when a service or a human user will want to redirect themselves to this original URL based on the mapping they have, they will just provide it to the API server and it will redirect it to the original site. Very simple service, but let's ask ourselves what can go wrong here. So it is kind of a problem to begin because you have a blank page. You don't really know where to start. But if you think a little bit, you can maybe ask yourself, what if a human user or a service will upload a malicious URL that will be shortened into something that doesn't look malicious because it uses a common format and it hides a malicious URL underneath. So, okay, this is a real threat, it can happen. And what you want to do, maybe you will want to implement a URL validation, for example, using a VirusTotal or a tool like that. And it might work. So checking the reputation of the domain and the URL. The second thing that can happen is that the attacker can try to, for example, execute an SQL query and inject SQL query into the mapping, and if not properly validated, the input will be executed on the database and maybe, I don't know, delete everything or show all the mappings. So you want to validate, sanitize your input, and make sure that everything that is saved into the database is validated and sanitized. And at the end, maybe there will be a request flooding, so request flood. So a user will generate a huge number of requests to shorten a URL or redirect to an original site. So you might implement a rate limiting, you might put something before your service, for example, some cloud services like web application firewall, or use a third-party tool to do that for you, and so on. So remember this diagram. We will go back to it when it will be a part about AI. But you know that this is how we can do threat modeling. So just look at the diagram and brainstorm.
In this part, we present how the approach to threat modeling look nowadays. And let's start with methods. Currently, we have quite a large selection of methods that may reflect our needs in the best way. And there's no simple answer on how to choose the best one. You may think, how big is your product? What do you want to focus on? So for example, risk or privacy. And do you need a diagram to visualize? Some of the methods actually cannot be named as a typical ones, but rather as a complementary to others, like for example, DREAD, DIE, or CVSS. Also, there is a quite popular concept of threat modeling as a code, and it's becoming increasingly popular. And it brings the principles of infrastructure as a code and DevSecOps approach. We can also use some other interactive approaches like card games or brainstorm sessions, and they can be actually a good opportunity for team integration. Also, some inspirations, let's say, can be found in various threat libraries or checklists like OWASP Top 10 list, CAPEC, CVE database, and other custom checklists. Coming back to tools, currently we have a variety of them. Most of them actually are dedicated threat modeling tools. They were created by the communities, like OWASP, or created by enterprises. Sometimes traditional methods actually can spark creativity and clarity through process, so don't overlook the simplicity of using basic tools like a sheet of paper and a pencil or a whiteboard. And remember that each tool serves a purpose, so selecting the right one is a key to success. One of the most popular framework is STRIDE. And STRIDE stands for spoofing, so pretending to be someone other, tampering, modifying something, repudiation, so claiming didn't do something, information disclosure, so accessing data by someone who shouldn't have access, denial of service, so denying access to legitimate users, and elevation of privilege, which means doing something without authorization. And STRIDE is actually a good approach for a structured product, making it easy to understand. It's good for a smaller and medium-sized products. However, for complex ones, it may be not efficient because it may be very time-consuming and some unique threats may be not covered.
Okay, so we know tools, we know methods, we know how it works at the basic level, and we might ask ourselves a question, what if we add AI to that? AI is now everywhere, so why not in threat modeling? We tried to think what is not working in threat modeling today. So as you have seen before, it's kind of difficult to kick off because we have a blank page and we don't really know where to start. I mean, it would be nice to have a clear starting point. So every application is unique, but in the end, it's not that unique because we use the same tools, we use the same frameworks, technologies, and we all use the same design patterns. And as the result, we kind of have the same threads. So this process in the beginning, it kind of looks the same because you need to go over the overwhelming list of threads, select the applicable ones, try to mitigate the threads that you found, and check if it worked. Also, if you don't have support from security engineers, it is difficult to perform a threat modeling session only within a team of software engineers because they simply don't have that much security experience. So the natural question to be asked is, how can we automate that? So you can see we divided that table into 4 sections, each one corresponding to the 4-step framework question. We only tried to automate the 2 middle points, so identifying what can go wrong and prioritizing threats, but also suggesting mitigations based on those identified threats. Technically, you could also go further on and try to automate the first step, so building the diagram. Software engineers use different tools than threat modeling tools, so they already have those diagrams somewhere else, for example, Lucidchart or Miro or whatever, and it is not really fun to just rewrite your entire diagram to another tool. So it would be nice to have a connection between your original diagramming software and your threat modeling tool, or merge it and use your diagramming software as your threat modeling tool. We don't say that it needs to be AI. It can be a script, it can be whatever, but we try to do it with AI. At last, when you want to automate the fourth step, which is, did we do a good job? Maybe adding threat modeling into the CI/CD pipelines might be an answer to require, for example, teams to have the threats of the higher priorities resolved. It still requires some manual action because somebody needs to put those threats in there, but maybe some checks like that would work. And we try to automate the step 2, which is what can go wrong, and step 3, so what can we do about that, using an open source tool called OWASP Threat Dragon. It was one of the tools listed in the tools slide. And we tried adding integration with LLM to try to come up with threats that will be applicable only to this service that you're modeling. It's not a rocket science underneath. It works just as you would think it works. So you just translate the diagram into text, you send it to ChatGPT or whatever LLM you use, and you get the response back, what can go wrong and what can you do about that. And the only thing that was needed was to properly parse that data and put it into the right places. So we ran some tests, and we asked 5 engineers that had previous experience with threat modeling to create a threat model for the same service that the OWASP Threat Dragon LLM created threat model for. And the results were kind of surprising, because it turns out that 90+% of threats were the same. So LLM were able to identify 12 out of 13 most common threats identified amongst engineers, and also suggested 7 out of 8 proposed mitigations. What is interesting, because that was the same service that you've seen before, LLM suggested to implement URL validation, for example, using some third-party tool like VirusTotal, and not so many. I think 2 out of 5 engineers suggested that security control in their proposed mitigations. Okay, so let's see how it looks in practice. Okay, where's my pointer? Okay, so this is how ThreatDragon looks like. So you have a project, you have a description of your service, you can have multiple diagrams. We have one because the service is very simple. So okay, let's go in. It is kind of the same. I also added authentication to this service. So if you want to shorten the URL, you need to have a valid API token. That's the only change. And technically, what you could do is go to each component, click register. I don't see the new thread. Okay, yeah. Click a new thread, fill out the details, and click apply. And that would work. So this is how you traditionally do threat modeling. You can use, of course, checklists. You can use threat libraries. There are many resources. But what you can also do is use the integration. So you can generate threats for only one component, but also for the entire diagram. So let's see how it works here. You can select how many threads you want to have identified and provide additional context to the LLM that will be added to the request. Let's not add anything. And in the background, it will translate the diagram. It will send requests to the selected LLM provider, and it will update the diagram based on that. So you can see that the colors changed. It means that there are some open threads in here. We can go into and see what are those. I don't see what are those because I can't see, but maybe you can see that one of those threads are, for example, malicious URL submission or request flooding or whatever. Yeah, okay, and based on that, you can see that you no longer have a blank page. You have something. You can totally remove those threads if they don't work for you, but at least you have something to start from. Maybe you will get inspired based on those threads. Maybe not. You'll see. So, is it a potential new feature? So, let's see what are the benefits. So, definitely time savings. You could see that it took under a minute to generate a few threads for the service I was modeling. The time is valuable. I mean, I'm pretty sure that threat modeling isn't the most important thing that software engineers need to do. So any time savings is a great thing. You no longer need to go through extensive lists. You have them in LLM. LLM learned on them, and it knows what you will eventually know. We have a baseline threats covered. So we have a list of threats that are common. You still need to go through specific threats to your service. We cannot just give threat modeling now to AI and handle that. But we no longer have a blank page syndrome. We have a clear starting point that we can work from. And it's interesting that sometimes you just knew something but didn't realize until LLM told you that. And this is for those cases. So you just realize, yeah, I knew that, but for some reason you didn't put that before. You can also get inspired by other threats. Maybe you read something, some light bulb moment come up, and you have another threat.
Speaking about threats, we can consider some data privacy concerns. So anything related with information that maybe should not be put into AI tools. So what in such situations? You can read policies of AI tools on how they process and store data. And if you still have some concerns, maybe it's better to not put something into the tool. Then you can also use self-hosted LLMs or LLM settings that disallow training on your data. Incorrect threats and mitigations. As we saw, this may be a big help in case of creating threats and mitigations, but they not always need to be correct. For example, they may be too general, not consistent with a given case, or even inappropriate. So what in this case? Human verification with some other security or software expert, use confidence scores, trace of reasoning or rationale behind each suggestion, or use any structured validation process. We can also mention about over-reliance, that sometimes AI can be treated as a help, but should not be treated as something on which we can blindly rely. What in this case? Ask for approval of each item if you have any concerns. Emphasize that the tool is there to assist, but not to replace something or somebody. Cross-check with other approaches that can be used, and ask for independent review. Okay, so what did we learn today? First, threat modeling is an important process that can help us with identifying threats and applying appropriate security controls. This is nothing new. As mentioned, it may be even mentioned in the prehistories, but recently it was, for example, greatly popularized by Microsoft by creating Stride method, threat modeling tool, and their method for risk register. Then we have many formalized methods that can be chosen depending on a given use case, and the same for tools. So we have a variety of approaches, and sometimes they can be even mixed with others.
Okay, and we learned a lot of approaches, a lot of frameworks and methods, but remember, they are only there to help you. They shouldn't formalize this process too much. If it doesn't work for you, just don't use anything, or use whatever it fits. The most important thing is to do something. It can be a 15-minute session, it can be 1-hour session. Just sit down with the team, think of the threats. You can use tools, you can use methods, but remember that anything will be better than nothing. And we currently observe AI takeover of everything, including threat modeling. It is not a new topic. Some proprietary tools have already included that in their offerings. It can simplify the process a lot. It has a lot of benefits, but it also introduces some risks. So remember that it's not that you can just give away your threat modeling to AI. You need to follow the right approach, the right implementation, and in that case, it will really enhance this process, but otherwise it will only be another security risk. Thank you very much.
Yeah.